Okay guys, we've got a little video on geometric sequences. It's obviously the follow-up to the one that I put out yesterday on arithmetic sequences. What's the difference? A geometric series is a series or sequence where each term you multiply by a common ratio. So for example, a geometric sequence could be something like 1, 3, 9, 27, where each number is being multiplied by 3. That's different from the arithmetic sequence, which is just a straight addition between term to term. So UN, SN mean the same thing they do for arithmetic sequences, and if you're not solid with those, I recommend looking at the previous video. UN means that particular term, so U10 would be the 10th term. SN means the sum of the terms up to that point, so I hope that's reasonably clear. What have we got here? We've got ARN to the minus 1 for UN, and we've got SN is that formula up there, a open bracket 1 minus r to the n, 1 minus r. Now those 1 minus r's can be reversed, so you could have it as a rn minus 1 over r minus 1. That's not the way that the proof shows it, so that's not the way I'm going to do it, but when I learnt it when I was a little kid, that's the way I remember. I don't think I was ever a little kid, to be fair, but you get the idea. What do a, r, and n mean? A is much as it was before the first term, r is the common ratio, and n is the nth term. So the only thing new there is r being a common ratio rather than d, the difference from the arithmetic sequences. As before, you might be asked to prove the sum, and here is the proof right here. How do you do it? You first of all write out Sn as the sum of all the terms. So the first term, the second term, the third term, all the way up to the nth term. Then you multiply by r to get Rsn. You subtract the two, factorize Sn on the left-hand side and a on the right-hand side, and rearrange. Now, again, you've got that common issue with this. It's like, why would you do such a thing? And again, I'm going to say to you, this is very much a recipe style. This thing proves the thing we want it to prove, so we'll excuse the fact that it's not obvious why you should want to do it in this particular order until you see the final answer. So I hope that makes sense. And that's all I've really got to say on this. Bye.